Hello everyone. Okay, we are from the group 8, and today we will present our control principle assignment, which the title is the DC-DC choke converter, and our topology for the converter is from the 18 watt to the 12 watt. And my name is Xiaoben Hong, and my metric number is B0820100043. And this electronic document is discussing the operation of DC-DC converter, which is step down the voltage input from 18 watt to 12 watt. And a choke converter can be seen as a combination of boost converter and buck converter, and it having a switching device which is MOSFET we using in this assignment, and a mutual capacitor to couple the energy. The operation mode 1 and mode 2 of the choke converter are stimulated by using the MATLAB software. The keyword are DC-DC converter, choke, mode 1, mode 2, and the MATLAB. So first, the introduction. Choke converter is a DC-DC based power electronic converter. It named after the Scrabble choke as its inventor. The choke is designed to overcome the drawback observed in the buck boost converter. As before we moving to the theory part, so we must know the DC-DC converter, so that we will know the choke converter function very well. So the input of the DC-DC converter is a fixed, and its output is controlled and regulated, which where its voltage is stepped down using a buck converter and step up using a boost converter. So the DC-DC converter can be designed in an adjustable manner in one simple topology known as the buck boost converter, where it can either step up or step down the voltage. So the buck boost converter is a very unique one, where the output of the converter will have the reverse polarity. Similarly, the choke converter works with the same duality principle, where the output of the choke converter will reverse the polarity similar to the buck boost converter. So in the end, the traditional DC-DC converter buck boost and buck boost converter have one capacitor, one inductor, one diode, one semiconductor switch, and the choke converter consists of two inductor, two capacitor, one diode, and one the switching device, semiconductor switch. And the use of the two inductor in the choke converter has a great advantage, so that the voltage ripple is less in the input and output side. So in this session, the theory operation will be explained from my teammate later. So my part is already finished. Okay, thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Adeni bin Kamaruddin. My metric number is B08201086. So today I'm going to talk about DC-DC choke converter. I'm going to explain for the theory operation of choke converter. So I'm going to explain about the theoretically of how choke converter working. So as shown in figure 1, which is this one, this one, the choke converter consists of total 6 components, which is L1, L2, C1, C2, and diode D, and also switch S. Okay, so before we study its operation, we will consider the ideal condition for the component, such as all of these components doesn't hold any charge. And then to simplify it, okay, so to make it easier to us to understand how it works, we are going to separate it to 4 cases, which is for cases 1, when the switch is on. So this switch is on. So as we said before, there is no charge in the current. Ideally, okay, so when there is no current in the capacitor inductor, and then the switch is on, the source will charge the inductor. Flow of current is observed from L1 to the switch and back to the source. The inductor L1 gets charged and acts as a storage element with polarity from positive to negative. So technically, there will be small amount of a stored voltage in C1. There is no flow of current to the load. So what it says here is that the current will move clockwise, and then there's only small amount of voltage in C1, and there is no flow of current to L to F to load. My bad. And then for cases 2, which is when the switch is turned off. Okay. The inductor L1 dissipates the stored energy by reversing its polarity. In addition to the stored energy dissipating from L1, the current will flow from the source to the inductor L1. The reason for the flow of current in the inductor is because the current flowing from inductor L1 is not completely direct current. So, so this is exactly like cases 1. So, and then we will proceed to cases 3, which is when the switch is turned on. Figure 4 show when the switch is turned on. Just as case 1, inductor gets charged. Current flow from a source and to capacitor and load, but now the charged capacitor will hold the voltage dissipate its energy to the load. The voltage stored in capacitor C1 act as a voltage source. When current flow from the capacitor C1 into C2 and load, it also charged the inductor L2 in this process, where diode is reverse bias. And then for the cases 4, which is when the switch is turned off. When the switch is turned off, repeat where ni charge ini, the diode is forward bias, where capacitor C2 and L2 dissipate the energy where the output voltage is reversed. Due to this topology of the on-off mechanism, we get a reverse polarity at the output when compared with the input side voltage. And then for the chip topology, in figure 6, this is the figure 6. Shares similarity with a boost converter capable of stepping the input voltage down and up, having reverse output voltage polarity. Component-wise, the tube converter has an additional inductor and capacitor compared with the 3 converter mentioned above. So, the power stage, I think, okay, so here let's proceed to equation part because I don't want to make it too long for my part as we need to combine with others part also. So, so in DC-DC converter operating in continuous condition mode, they exit to state 1 when switch is on and other one where switch is off. So equation for the circuit when switch on, which is X equal to A, X1 plus B, V1 D. And then during switch off, this is the equation. And then to produce an average description of the circuit over a switching period, the equation corresponding to the two foregoing states are time, weight, and average, resulting in following equation. So this is the equation. So I think that's all for theoretically part. So and then let's proceed to result part, which is will be going to present by other groups members. So thank you.
Assalamualaikum. My name is Abdul Hakim bin Mustafa. For today, I want to explain for DC-DC tube converter for input 18 volt to output 12 volt. For my part, I will explain about the result. Okay. At the beginning of to construct the circuit, we need to find the value for the component for resistor, capacitor, and inductor. From the parameter given. We know the voltage input 18 volt and voltage output 12 volt or negative 12 volt. And we assume frequency 50 kilohertz and power 40 watt. For the duty ratio, we will use the formula D equal to negative V out over Vs minus V out. So we get 0.4. For current inductance, we will use this formula and we get also inductor 1, inductor 2, same formula. Okay. For change and we need to find the rate of change in inductor. Okay. To find the value of inductor, first inductor. Okay. For value of capacitor, we will use this formula 1 over minus D duty ratio, and we get almost 7 microfarad. Okay, this is a rate change of the capacitor in capacitor 1, and then we will find the RL and C1. Okay, then after get all the value of the component, we will construct the circuit DC-DC tube converter. This is our circuit that we construct using Simulink MATLAB. Okay. This is the output for the Simulink. We can find. Okay. We will run first. Okay, for this waveform, we need to zoom in the scale because the scale is very small. We will zoom in. This okay. This is waveform. Same with the upper and the top and the bottom waveform. We need to change his scale too, and we will get the result same like this. Okay. Then for the state space equation for the tube converter, this is the formula. For the mode 1 is the switch on. Okay, and then this is a equation for state space mode 2. Mode 2 is switch off. Okay, this is a metric for the formula, and then this is a state space mode 1 calculation. For this I assume to get the easier way to get the solution. Lastly, I will get the like this, and I will enter the value to the coding in the MATLAB to get the waveform, and then this is the coding for our project. After we calculate the state space, and we will run. Okay. Okay, this is our waveform for unit step response from state space method. And that's all from me. For the next, my friend will explain more about the conclusion and the acknowledgement. Okay, thank you.
Hello, my name is Muhammad Fidan bin Aziman, matrix number B08 2010-403. So for the conclusion is the chart converter output voltage values can be higher or lower than input voltage. In addition, the harmonics of input and output current will be lower because of the inductors. These dominances are corresponding to PV application compared with different converters when it is operated in CCM mode. In CCM mode, the chart converter can sweep whole IV curve of the circuit to get more smooth output current, so it is necessary to have the closed loop control strategy and the control strategy P&O for PV application. So for the acknowledgement, we would like to appreciate and express our sincere gratitude to our supervisor, Dr. Hafiz bin Zakawi, for his professional guidance, support and encouragement from the beginning to the end of this assignment. Furthermore, we would like to thank our teammates for their cooperation given to complete this assignment successful. Finally, we would like to share our best wishes and blessing to all the writers whose works and reference in this study as source of information. So thank you, that's all from us.